Hey, wake up! Get out from behind there. Today I'm teaching you about conservation of energy, so drink this and get ready. First of all, do you know what a unit of energy is? Well, a unit of energy is called a joule, and it's produced when you lift an object of 100 grams, like the apple, up 1 meter. Energy can be of lots of different forms. Electrical energy, heat energy, kinetic energy, and sound energy. Energy can only be transformed, it cannot be created or destroyed. Everything uses transformation of energy of some sort, all those that you saw before, but also others. Like the movement of your hand being turned into sound on a guitar. Or in a lighter, turning chemical energy into heat and light energy. Kinetic energy is worked out with the formula E equals half mv squared, which means you square the velocity times it by half the mass of the object. Potential energy is worked out with the formula E equals mgh, which means you times the mass of the object by its height off the ground and the acceleration due to gravity. So how does this conservation principle work? Well, at the moment, you're high up in a building. If that little guy fell out the window... No, you can't just throw him, the glass is in the way. We'll have to find another way to demonstrate. You mean you want to do it, when you get hurt? You see, when you fall, you turn all the energy you gained from climbing this building, or potential energy, back into movement or kinetic energy. So the only way you've got to go is down to the ground. This is why it hurts so much. You have so much energy from falling that it's worse than being hit by a bus. Now, here's the important bit. All of this is assuming there are no external forces. Since there aren't any when you're falling off a building, nothing pushes you much while you're in the air. The total of the kinetic and potential energies will remain the same. So there you have it. That's what conservation of mechanical energy means. And no, climbing those stairs does not follow the principle. You're exerting a force. Where is it used? It's used everywhere. Take a wrecking ball as an example. If you let it go without pushing it, then it will swing to the same height on the other side. All the potential energy gets turned into kinetic on the way down, and then back to potential on the way back up. If someone is standing the same distance away as you are, then it won't hit them, and it will come back to you without hitting you too. However, if someone swung it at you and you were closer, then it will wreck you, just as the name suggests. Same as before though, we have assumed there aren't any outside forces, and this isn't quite correct. If we were to let the ball swing for long enough, it would slowly swing less and less far, as the air reduces its speed over time. As engineers, this is very important to us. We need to keep this in mind when designing anything that will move vertically and horizontally. We wouldn't be able to design things like roller coasters, and we wouldn't be able to go skiing without it either. It's a very important principle, and you'd better keep that in mind next time you want to jump off a building. It's also used in generating power. Dams use this to produce electricity from water flowing through their turbines. We can also tell how much energy can be produced using the height and flow rate of the water.